Alright guys, for this unit I am going to try my hardest not to say like, these are short notes, these are long notes, because I know it's driving some of you insane. So I'm just going to say, hey look, this is Isotope Notes. Let's start these notes with the first question. What is an isotope? An isotope is an atom of an element with different numbers of neutrons inside the nucleus. So you're going to have atoms that weigh lighter because they have less neutrons, and you're going to have atoms of that same element weigh bigger because they have more neutrons. So let's see what this looks like. Here we have two different isotopes of the atom lithium. Now lithium has 3 protons according to the periodic table. And if it's an atom, it's also going to have 3 electrons. So you see that each of them has 3 blue dots in the middle, representing those protons in the nucleus, and 3 red dots on the outside in the rings, representing the electrons. All right, so what you also see is the one on the left here has 3 neutrons as well. Those are the green dots. Whereas the one on the right has 4 neutrons. Okay, so these 2 elements of lithium are what we call isotopes because one of them has 3 neutrons and the other one has 4 neutrons in its nucleus. This accounts for why the atomic mass that you see on the periodic table, that number underneath the symbol, is not a whole number on the periodic table. If you notice, all of them are going to be decimals. Okay, in fact, for lithium's atomic mass is 6.94. Okay, that decimal 6.94 is the average mass of all the isotopes of that element lithium. So again, we have that decimal number on the periodic table because we have different isotopes of elements that have different numbers of neutrons in them, and so to get the average mass, we would have to average out, add them all up, and divide by the number of atoms of that element to get an average mass of all the isotopes. So that's what we see on our periodic table. Let's move on to our next question, which is what symbols are used to represent isotopes? So when we're talking about different isotopes of an element, we have a certain symbol that we are going to use in order to represent it. Their symbol is based upon the fact that, remember, isotopes have the same number of protons, because if they had different number of protons, then we'd be talking about 2 different elements. Okay, so the isotopes have the same number of protons, but different numbers of neutrons. So that means that their masses are going to be different. And so the isotope symbol revolves around the fact that we have the same number of protons, but a different mass. So let me show you. Here you see represented 2 different symbols for the isotopes of boron. Now if you look at your periodic table, boron has the symbol big B. Okay, and here we've got on the left-hand side, the top number next to the B is 10, and the bottom number is 5. Now, if we look at the periodic table, the 5 is the number of protons. In fact, we can see that the number 5 is in both of our isotopes. So we know that's got to be the number of protons since the proton number is the same in different isotopes of elements. So the top number must be our mass. Okay, so the isotope on the left, it has a mass of 10 versus the isotope on the right has a mass of 11. So when we look at symbols for isotopes, we can very, very easily do a little math to figure out how many neutrons are in that isotope. What we do is we take our mass and we minus the number of protons to figure out neutrons. So on the left, 10 minus 5 is 5, so this one has 5 neutrons. And on the right, 11 minus 5 is 6. So the one on the right has 6 neutrons. Okay, so it's a super easy way to figure out the number of neutrons from an isotope symbol. Now, right underneath those isotope symbols, you see this box for isotope symbols. Please jot this box down in your notes. Okay, it tells you exactly what each of those numbers and the letter means in an isotope symbol. So again, here we see that the top number, okay, is what we call the mass number, and the bottom number is the atomic number. Remember, atomic number is the number of protons, and the mass number is the mass of the atom, which is made up of protons and neutrons added together. So that's one way we can represent isotopes. Another way is to just refer to them by their name and their mass number. Okay, so here down here on the bottom, we've got boron, just the name, and then 10, which means it's the isotope that has a mass of 10, versus boron, again, 11 this time, which means that this isotope has a mass of 11. Okay, so that's another way you can represent isotopes. You will use both ways tomorrow in your activity. All right, let's take a look at our third question. How do I calculate the number of neutrons in an isotope? When we look at our periodic table, we can figure out for an element how many neutrons at least 2 isotopes will have. Okay, and so this is the basic steps on how to do that. So here are the steps. Now they're kind of long, so you're going to want to pause it in order to write it all down. But basically there's 2 steps. You're going to take a look at the atomic mass, that decimal number on the periodic table. So if you take a look down here at the bottom left, we see here's the periodic table little card for neon. And the atomic mass, here the average atomic mass is 20.18. So you're going to round the first step is to round the atomic mass down to the nearest whole number, then subtract the number of protons to get the number of neutrons in one isotope. So if we do that for neon, we're going to first round that 20.18 down to 20. Okay, so we just take that 20, and then we're going to subtract the number of protons. So, well, that's the 10 right up here on the top. So 20 minus 10 is 10. Okay, so that's the first step. Now the second step is to round the atomic mass up to the nearest whole number. So if we take a look, 20.18 over here is between the number 20 and 21. So if we round it up, we would get 21. Now we subtract the number of protons from that, and we get 11 neutrons. Okay, so we've got an isotope of neon that will have 10 neutrons, and another isotope of neon that will have 11 neutrons. So that's kind of an easy way to use our periodic table to figure out at least 2 isotopes of an atom. Now you'll see in tomorrow's activity that some atoms have a lot more than just 2 different isotopes. In fact, some of them have up to 10 different isotopes, 10 different numbers of neutrons that can be in the atom. So we'll take a look at that tomorrow. Now the last thing I wanted to mention before we leave this slide is the abundance, okay, or which isotope is more commonly found in nature. Now we have to take a look again at our average atomic mass. The average atomic mass is 20.18. So if we think about it, most of the mass of the atoms is going to be closer to 20 atomic mass units rather than 21, because 21.18 is a number closer to 20 than 21. All right, so what that means is that the isotope with 10 neutrons in it is what we call more abundant in nature than the other isotopes of 11 neutrons, or if it had any other types of isotopes in it. So again, you have to look at your average atomic mass to figure out if it's closer to the lower number, then that's going to be the number of neutrons that's more abundant. If it's closer to the higher number, then it would be the other set of neutrons that is more abundant. We're going to end these notes here with question number 4. What is the average atomic mass on the periodic table? So we've been talking about isotopes and elements with different numbers of neutrons. So we can have the same kind of element with different numbers of neutrons. So basically the average atomic mass is going to be the decimal number, okay, that we find on the periodic table for each element. And it's going to be the average weighted masses of all the isotopes in a sample of that element. And remember, the most common isotope of a particular element is going to have a mass that is close to the average atomic mass on the periodic table. So, for example, if we are doing boron, and we look at the periodic table, and boron's average atomic mass is 10.81, right? So you have to ask yourself, is it closer to 10 or is it closer to 11 as we round up and we round down like I showed you earlier? Well, in this case, right, this is closer to 10 or closer to 11, okay? So we're going to say that's closer to 11. All right, so our boron 11 isotope, boron 11 isotope is more abundant. All right, so is more abundant. So we find the boron 11 isotope, or the boron atom that weighs 11 atomic mass units, that has 5 protons and 6 neutrons, more abundantly in nature. All right, so that's how it works with isotopes. All right, we'll see you tomorrow for our activity.